But let's see this example. So we have a function written here in C language. Okay, so you know, if you are already familiar with C language, you know how the functions definitions are written. So int abs is the name for the function. Assume that this is the same machine. Okay, and we have to provide some input. So assume this is abs. Okay, this is abs system. So this input n is supposed to be going where? It has to be provided into this machine, but we cannot just provide n into this. We cannot just pour in n here. Okay, we have to place it here in a separate register, which we call argument register. Okay, so there is a specific register in argument. I think I should share this with you guys. It's for your own reference. It will help you remember what registers are. Pass this one also. There are more students on this side. So there are registers from x10 to x17. Okay, so x10 to x17 registers are used to hold the arguments. Okay, arguments, the inputs that we want to pass to the function. Similarly, it stores the output back into the same registers, starting from x10. Okay. And how does the function pass the return value to the caller? We have already discussed this. So this is the function which takes the n as an input, and if n is less than 0, means if n is negative, then it changes its value. I mean, it changes the sign, turns it into positive, and then return its value. Okay. So I have already specified that there are 8 parameter or arguments registered x10 to x17, which we can use to pass the input to the machine, to the function. Okay, and then machine can also store the output back into the same registers. So if there is only one output returning from the function, it will be stored in x10. Consider this as an x10. x10 was used as to provide the input, and the machine is also storing the output in the x10. If there are more than one output, then it will be starting from x10, x11, x12, x13, and so on. Okay. Or in RARs, it is usually referred as arguments register A0, A1, and A7. Okay. 2 values can be returned in x10 if there are only 2 values that we are returning. If only one value, it will be stored in x10. Caller and callee communicate through these registers only, and that's why we call this as an interface to the rest of the program. So the rest of the program, how does the rest of the program communicate with the function? Through the help of arguments, through the help of these registers only. Okay. Function cannot assume S1 has an address it needs. So S1, if you look at the reference sheet, S1 corresponds to the saved register 1. So in order to communicate or pass the values to the function, we cannot store our data into safe registers. Okay, we always have to pass the values into argument registers. So this was our program. If we have to call it, so assume that we are passing the value -2 to this function abs. So how we actually call this function with -2 as an argument? What we will do is we will first set A0. A0 corresponds to, again, x10, which is the argument value register 0. We initialize it with -2. Okay, just like we are initializing the input ingredients in this. Consider this as an A0. Okay, so this is A0, and then what we do is we call the function abs. So that is the function abs. Okay, now this function will automatically read the value from A0 because it knows that the argument is stored in this register. Okay, so the code would look like this: BGE A0 X0 exit, checking for the condition, this one. If n is less than 0, then jump to exit. If it is not, then what it is supposed to be doing is we have to execute this one. We have to invert the value of A0. So how we can invert the value of A0? By subtracting a value with X0. Okay, so X0 already contains the value 0. if you are subtracting something from 0, it will just change its sign. Okay, so if the number is negative, this instruction is going to execute and it will change the sign. RV contains the value of -n. Okay, and in the end what will happen, it will return where it is supposed to be returning. How will it return? It has to return to the next instruction, and the next instruction is stored in RA. Okay, RA holds for the return address. So this another register RA will be holding the instruction which is supposed to be written up here. Okay, any question? Again, we are just not trying to understand what is the code about, but our concern is how the argument values are passed to the function, and where and how we can return back to the next instruction after written after the caller instruction. Yes.
How does the function know which register to look at for input?
For the input? Yes. So function always starts looking from A0, which is x10. So if you look at this sheet here, so there are registers from x10 to x17, which is used to communicate with the functions. So before calling the function, what we did is A0 again corresponds to this x10. Okay, A0 corresponds to argument 0, argument 1. So any argument that we want to pass to function, we have to store its value in A0. Okay, so when this before calling the function, we have to store the value A0, the value -2 into A0. Get it? Now when the function starts executing, you have to write it in a way that it should read the value from A0. So since we are learning to write the code ourselves, but when you are developing a compiler, for example, you come up with your own language, and that you might end up working for such companies who will be developing compiler. So you have to write the instruction, the procedure in a way that when some function is called, so the higher level instruction is translated into this kind of assembly code, which should be reading the data from A0. Okay, A0 corresponds to again the first argument. If you have like multiple arguments that you're passing into function, let's say A0, it will be first argument will be stored in A0, and then A1, A2, and A3, and so on. Okay. Similarly, once the function is processed, then the output produced by the function will be stored in A0, starting from A0. So previously, whatever input you have passed, it will be overwritten. Okay.